Hello everyone. In this video, I'm going to show you how to use templates and top-down design in SolidWorks Assembly. And we're going to do it by a simple jewelry box here that you can make out of cardboard. So this jewelry box has an inner volume that you want to put everything in. And that is a part that is like a basis for this. And then you have a bunch of cardboard pieces that you have. So there is one at the bottom, there are 4 on the sides, there is one here on the top, and then 2 smaller pieces here. So the goal is to show you how to create these 8 pieces, all based on that inner volume. And so the first thing we bring into assembly is that inner volume that we made already. And then inside the assembly, we're going to make all of these other files. So it's a top-down design, and all of these files share one dimension, and that is the thickness of the cardboard here, which is like 4.3 mil. So we want to know how to share some data, some equations, some parameters like a global variable among several files within an assembly. And you might say, well, just this basically export your equation parameters as a text file, and then import them into wherever you need them. And that's right, we can do that. But when the number of components in your assembly increases, you have to insert that text file and import that text file, including your equations, into each and every one of them. Because if not, then these files that you made inside the assembly do not have access to the parameters of the text file that you imported into your assembly. So these individual components don't have access to assembly equations and parameters. So the way to go about it is to create what we call a template. And this is what I'm going to show you from scratch here. So here we are going to create basically the inner volume, and the dimensions for it are 130 by 80 by 80, and there is a thickness that I want to create right here as well. Okay, so first thing is, let's go ahead and create the template file that we're going to be using. So I go here to the tools and options, and I'm going to go under document properties and set the units to mils. That's another thing that you can share when you use a template. So the default, you see, the default units is inch system. But if my parts that I want to make in assembly, they are using millimeter, each time in each one of them, I have to go and change the units. But if I use a template for all of them, I don't need to do any of that. Each part that I make out of a template will share the same unit and any other property that I set up. For instance, if my dimensions have to be shown with 2 decimals or 3 decimals or with any font size or anything I want, any property, I can share it. So look here, I say I want all of my templates to use the millimeter system. And I also want all of them to share some parameter. What parameter? In this case, that's the cardboard thickness. So that is 4.3 millimeter. And I can add some comment here and say this is the cardboard thickness, right? So any other equation, any other parameter that I want, I can share it here. And now, instead of saving this as a part or anything, I go to File, Save As, and now I'm going to save it as a template. And you can see one of the file formats in SolidWorks is Part Templates, or PRTDOT. And when you save them, they are saved in this folder. Okay, it's under SolidWorks Installation, under Templates. So all of them will be stored over there. So you see I already made one, but here I call it maybe new template or something. Okay, so now any file I want to make, I can use this new template and I can make it based off of this. So let's go ahead and first make the inner volume part. Now the inner volume part does not need to be exactly from the template. So I can just go ahead and make the part here. And now I can go ahead and make that part. So here we go. It's a center rectangle, 130 by 80, and extruded for 80 as well. Okay, you can apply material, but in this case, it's not really needed. So here we go. And now we are going to extrude it for 80 like this. And now I'm going to call this the inner volume. Okay, so here, and I'm gonna save it under my downloads or any folder that you like. So inner volume, right? And then I'm gonna make the rest of my assembly components around this center part. So here I'm gonna create a new part and I'm gonna make a new assembly. Now, one of the things I can do is this, and I can do it inside assembly, or I can do it right now. I can go to my options and then look here under default templates. The default, when you go to default templates, it is always on this guy. It says always use these default templates that are in those folders, but you can change it to this one. So it asks the user to pick any template that you like. And here, if you have any template in a location other than that installation folder, you can add them elsewhere too. But so it also going to look under downloads now for any template and then ask the user to use the template that you want. So now look, when I go ahead and start a new one, you see not only it allows me to pick a part, assembly, or drawing, which are basically 3 templates in that folder. Now I can start a new template or a my template. Okay, so right now I just want to go to assembly and I want to insert that inner volume here. There we go. Yes. So far, nothing special. Now is the part that I start the top-down design. So I go to insert component, but instead of inserting an existing one, I create a new one. So I click on new one. Now you see, I can say, hey, make it from the new template for me. What does that do? It will, this part that I make, this new part, will have the same units and will have that share variable t like a global variable, and I'll show you that. So look, first I make this part float so I can assemble it, and I right click on it and rename it. So maybe I call it the bottom piece or the bottom panel or anything that you like, right? And now what? Now I'm gonna right click on this and go to edit part. And now I'm inside this part. So now I can go ahead and start creating this part, right? So let's say I go to the top plane and start to sketch. And so here I pick the object and then I use the offset. And this offset should be equal to my cardboard thickness, right? So if I ask here to go with t, it's not going to do it, okay? So offset entity does not allow to use a global parameter. But right now I can just type in any number, let's say 4 or 5 or anything, okay? And you should get rid of the equal, of course, so just 4. But first thing first is look at the unit that you have. The unit in this file is already set to mils. And this is a big number. So now I can double click on this and say equal to, and now look, I have access to the global variable t. And as soon as I OK that, there we go. It is changing to 4.3. And guess what? Look at underneath this file. It already added the equation and it already added the cardboard thickness. You see, that is the meaning of template. This equation is already inserted. The units are already changed to mils without me doing anything because this file is taking advantage of the template. So now that the sketch is made, and by the way, which part is top-down design? The part that I'm using the dimensions of the inner volume and I'm just giving it an offset. So this sketch that I made is based on the sketch of the inner volume with some offsets. So I'm already using that sketch to reference my own sketch, okay? And then I'm gonna extrude this. And again, for extrusion, I say this is equal to the thickness of the cardboard. Done. So now this bottom piece is done. I okay that, and you can see the bottom piece here. And now I can save it. And when you save this whole assembly, let me call it the jewelry box or cardboard jewelry box. It is asking you, do you want this new file, which is the bottom piece, to be saved inside the big assembly file, or do you want to save it externally as its own file? So here I would rather do it as a separate external file, and I can do that, and I can also add prefix or suffix, right? So look, right now, the way I picked it as saved as with reference, that will be always referred back to the cardboard jewelry box. And again, I can add a prefix or suffix to do that. Or as I said, let me do it again. So if I go back to my downloads, and let me save it under downloads, cardboard jewelry box. Okay, if I save that here, I can say save without in context reference. So if I do this, now it is asking me, hey, do you want to do it internally or externally? My preference is to always do it externally, but you can save it internally inside the assembly. So your assembly has only one file, not a bunch of individual components. So I prefer to have the individual files. There we go. So now this one is made, and I can apply a different color to it just for better visual appearance. So let's say make it orange. Now I can constrain it. So I need to put this guy exactly in the middle of this and make them coincident. So what you can do is to put a coincidence between this surface and this surface, and then provide offset between these two faces and these two as much as the thickness of the cardboard. Or instead of all those three, there is an advanced mate. So you can go to the mates, go to the advanced. This one is called profile center, and this one does it much faster. So I say, hey, put this guy at the center of this one. Done. Look, it puts it exactly in the middle, and it applies a coincident as well. So now look, if I try to move this, this component is fully defined, is perfectly fixed and done. So that bottom piece is now fully assembled to the bottom of the inner volume, okay? And this inner volume, again, you can make it, for instance, a little bit transparent, because that's what it is just really volume. It's not a physical object. So maybe I can make it a little bit more transparent like this. There we go. Okay, now I need to create the cardboard pieces for the left and right, front and back, and then I want to make a curved top surface. So let's go ahead and make another piece here. So again, insert new part. Again, you see, it is allowing me to pick a new template as opposed to the default part template in SolidWorks. So I say, okay, give me a new template. It does. And right click and float it again, and then rename it again. So this one I call maybe left right panel, or yeah, that's fine, left right panel. Okay, and then I will right click on this and go to edit part. Then I can expand this, and then go to maybe the right plane here, start the sketch. Now it has to basically have these edges, but also it has to have this extra thickness. So I can pick a rectangle command if you want, and I can start here, and I can go all the way to there, something like this. Force this line and this line to be collinear. And then the offset between this one and this one, I can make it to be equal to the global variable t. There we go. You see, again, I have the units of mils in this part. I have the same parameter in this file, and I can use it. So I'm sharing a global variable here. And again, I'm going to extrude it as much as t, because that's the cardboard thickness. And done. There we go. So this is the left and the right panel, and I'm gonna save it, and I'm gonna save it externally. I'm gonna apply a different color to it, and I'm gonna constrain it. So here it is. And now I'm gonna force this face and this one to be coincident. Now you might say, can you use the profile center again? No, not this time, because this time the bottom of this piece has to be flush with this top surface, not with the bottom surface. So I cannot do that this time. So I pick these two guys and force them also to be coincident. And then I force these two surfaces to be coincident. And now the piece should be completely in place, you can see. And from every side is perfectly flush. Now for the one on the left, I'm not going to redo this whole thing. I'm not going to even try to copy one to the other side and then constrain this, because that takes more time. I can just mirror that. So I go to linear component. Underneath that, there is a mirror. So I can apply the mirror with respect to which plane. So if I go to this fixed part here, I can use the mid plane of that, which is this right plane, and the component to mirror is this one. And there we go, done. And it's already constrained because it's mirrored. So it's fully defined. I don't need to do anything for it. All I might need is to change the color of it. Okay, so this is how you do it fast. There we go. So far, 3 of the cardboards are made. Now I need to make one for front and back. So let's go ahead and do that one. Again, insert new part and new template again. And float it, rename it. So I call it front back piece or panel. Again, doesn't matter. It's just a name. So it's good to go. Right click, edit parts, go to the front plane, start the sketch. Now this one, again, I can use a rectangle and I can go from here to here. I do not even need to share a global variable this time because I have all the dimensions. But if you want, for instance, you can get rid of this coincidence here, right? And then you can provide, for instance, this offset and say, hey, this offset, by the way, is as much as what? As much as t. So this is equal to t. That's another way to do it. And then here, of course, this edge is floating as well. So you can basically get this one and force them to be collinear. So there are so many ways to do it. And again, it's done based on the sketch of a previous part. So it's a top-down design. And now I can just extrude it as much as the thickness. And that's all I need. So I'm going to bring it to the front and I'm going to change the color of it. And now I'm going to constrain it. So here we pick these faces to be coincident. That's one. Then, so let's see what else. So another thing we can do is get these guys to be coincident. Perfect. And finally, we need to make this one and this one coincident. Now the parts should be fully assembled. You see it's not moving anymore. It's in perfect position, flush with everything. Now I'm gonna mirror it in the back. And again, I pick the mid plane of this fixed part and the component is this. And here we go, one on the back, extremely fast. So let me just change the color of this and then we go for the top piece. So done. Okay, now let's do the top piece. The top piece does not really need a template, but I'm gonna use the same thing. It's fine. So here, let's create the top piece. So new part. And the good thing about it is at least it has the units that I like, millimeters. And so I call it the top piece. And now I guess I'm ready to create that. Can go to the right plane and I can start the sketch. Now this is an arc part, so I use 3-point arc, and between this point and this point I draw a semicircle like this. Make sure this is 180, and then between this point and this point I do another one like this, and then I connect them with a line to make a closed profile. There we go. It's ready. Now, how much should you extrude it? So when I go to extrusion, you might say, well, it should be 130 because that's the width of this part. But the matter of fact is now we have two cardboards on the two sides. So it should be 130 plus 2T. So this is the place that you need T for the, not for the sketch, but for the extrusion. So here you say T times 2, this is for the two cardboards on the left and right, and then plus 130 mil. Okay, so now this should be exactly the right size, and I'm gonna show you why. So let me first save these parts before anything happens and recolor this part here, and then we are going to assemble it. So here I pick this face and this face and force them to be coincident. There we go. Then we close this and let me rebuild it. There we go. So then, since these faces are good, I need to force the edges to do the job. So I can move it sideways, as you can see. And so I'm gonna force this edge and this one to be coincident as well. Now, is it done? So if I try to move this, you see it can still pivot about that edge. So now I'm gonna force that one and this one also to be coincident, and that should remove all the degrees of freedom. So now the part is completely in place. All you need to do now is to make this kind of semicircular parts, two extrusions for them, and you should be done with it. So let's make the last piece and so float it, rename it, and I call them top side pieces. Okay, I guess now we should be able to go in and design them. So for this one, I can just pick this piece and pick this piece and use convert entity, and then trim the remaining portions like this and this. Done. Okay, you see, that is the advantage of top-down assembly, is everything is done based on the previous part. And the bigger advantage is if I go ahead and change the dimensions of this inner piece, guess what happens to all of the other pieces? All of them will be adjusted accordingly. So if I decide that I want a bigger or smaller inner volume, my cardboards will automatically resize, because once I change one sketch, all the other sketches which are based on that will adjust accordingly, and so I don't need to redesign everything. And that is the big advantage of basically top-down design. So here I made the sketch, and again I'm going to extrude it as match as the global variable t. There we go. And all I need to do is to give it some color and properly constrain it and then mirror it to the other side. So there we go. Now I'm gonna pick this arc and this arc, and I'm gonna mate them. And since they are arcs, I make them concentric, and to not allow them to swing about. I can lock the rotation, so that takes away 2 degrees of freedom. So now if you look at them, this part, if you try to spin it, it is not going to work. But if you didn't do that lock, this arc and that arc would stay concentric, but you can swing this basically like a pendulum. But right now, because you locked the angle and you initially started this horizontal, that is like perfect angle. And now all I need is to force these two to be coincident. And that should make it fully defined. Look here, fully defined, done. Finally, I do one last mirror. And again, the middle piece of the fixed part, the middle plane of the fixed part, which is this, and this component to mirror. And I should get my other part on the other side, and I can recolor that. There we go. Done. So now your entire cardboard assembly is done. They all use the same units. They all use the same cardboard thickness, so they share the same global variable, and the design is done as top down. So hopefully the video was useful to you, and thank you for your attention.